Steel is so common that most of us rarely think about it, yet nearly every modern achievement depends on it. The bridges connecting our cities, the skyscrapers defining our skylines, the trains carrying millions of passengers, the ships moving global trade, the wind turbines generating renewable electricity, and even the factories building tomorrow's technologies all begin with one material. Every year, humanity produces almost 2 billion tons of steel, making it the backbone of civilization. But before steel becomes the buildings, vehicles, and infrastructure that shape our lives, it must pass through an extraordinary industrial process hidden inside one of the world's largest machines. This is the story of that machine and how hydrogen is transforming it for a cleaner future. Behind every modern steel mill stands a machine few people ever see: the steel reheating furnace. Stretching for well over 100 meters, this enormous insulated chamber is designed to do one job with extraordinary precision. Massive steel slabs enter at one end while glowing orange hot slabs emerge from the other, ready for rolling into the products that power our world. Every hour, hundreds of tons of steel travel through this furnace. It operates continuously, 24 hours a day, maintaining temperatures approaching 1,250 degrees Celsius, while controlling every stage of the heating process. This hidden machine quietly powers much of the global steel industry. Freshly cast steel is solid, strong, and incredibly difficult to shape. At room temperature, it resists bending, stretching, and rolling. To transform thick slabs into thin sheet, structural beams, railway tracks, or pipelines, the steel must first become flexible without losing its strength. That requires carefully controlled heating. As the slabs move deeper into the furnace, their internal structure begins to change. Heat penetrates from the surface toward the core until every part of the steel reaches nearly the same temperature. Only then can the material be safely rolled into the countless products that modern industries depend upon. Stepping inside the reheating furnace reveals an environment unlike almost anywhere else on Earth. Rows of high-performance burners line the roof, generating precisely controlled flames that fill the chamber with radiant energy. Beneath them, steel slabs slowly advance on a roller hearth through multiple heating zones. Every wall, ceiling, and floor is engineered to contain enormous amounts of thermal energy while protecting the structural steel surrounding the furnace. Although the environment appears almost simple, thousands of engineering decisions work together to keep temperature stable, protect equipment, and ensure every slab follows exactly the same journey from cold steel to glowing hot metal. The process begins as cold steel slabs arrive at the furnace entrance. Each slab weighs several tons and moves steadily onto heavy-duty rollers that guide it into the heating chamber. At this stage, the steel is dark gray, rigid, and unsuitable for rolling. As it advances, the surrounding temperature increases gradually rather than all at once. This carefully controlled progression prevents thermal shock and protects the steel from cracking or warping. Every movement is synchronized, allowing multiple slabs to travel through the furnace simultaneously while maintaining the exact spacing required for efficient heating. For decades, reheating furnaces relied primarily on natural gas to generate the extreme temperatures required for steel production. While effective, combustion of fossil fuels releases significant amounts of carbon dioxide. Today, a new alternative is emerging. Instead of burning natural gas, hydrogen can supply the same high-temperature heat while producing water vapor rather than carbon dioxide at the point of combustion. Blue hydrogen pipelines now replace traditional fuel lines, delivering clean energy directly to the burners. The furnace itself changes very little, but the fuel feeding it represents one of the most significant transformations occurring in heavy industry today. At the heart of this transformation lies the hydrogen burner. Inside this precisely engineered device, hydrogen mixes with carefully controlled amounts of air before ignition. The resulting flame burns intensely, delivering the radiant heat needed to raise massive steel slabs to more than 1,250 degrees Celsius. Every burner must maintain stable combustion while distributing heat evenly across the moving steel below. Too much heat in one area or too little in another can affect the quality of the final product. Thousands of hours of engineering, combustion science, and control technology come together inside each burner, quietly converting clean hydrogen into the thermal energy that drives one of the world's largest manufacturing industries. Generating extreme temperatures is only part of the challenge. The real engineering lies in transferring that energy into the steel efficiently and uniformly. Unlike a household oven where hot air does most of the heating, A reheating furnace relies primarily on radiant heat. The hydrogen flames heat the furnace walls and roof until they glow with stored thermal energy. That energy then radiates toward the steel slab from every direction, allowing heat to penetrate deep into the material without direct contact. This invisible exchange of thermal radiation is one of the most efficient ways to heat massive pieces of steel while minimizing energy losses. Every second, an enormous amount of energy moves through the furnace, yet it does so with remarkable precision. As the steel travels deeper into the furnace, its temperature continues to rise through carefully controlled heating zones. Engineers cannot simply expose the slab to maximum heat immediately. Instead, temperature increases gradually to protect the steel's internal structure and maintain consistent material properties. By the time the slab reaches the hottest section of the furnace, its surface glows bright orange while heat has penetrated toward its core. Around 250 degrees Celsius, the steel becomes soft enough to roll into new shapes without compromising its strength. Heating steel is not simply about reaching a target temperature. Every millimeter of the slab must reach nearly the same temperature from surface to center. If one section remains cooler than another, rolling forces become uneven. Product dimensions drift outside specification, and internal stresses can develop within the finished steel. Modern reheating furnaces continuously balance heat transfer across the entire slab, ensuring that the outer surfaces and the core reach equilibrium before the steel leaves the furnace. Surrounding the intense heat is another hidden engineering system that makes continuous operation possible. Every interior surface of the furnace is protected by thick refractory lining made from advanced ceramic materials capable of withstanding temperatures far beyond what ordinary steel could survive. These specialized layers trap thermal energy inside the furnace while shielding the structural framework from extreme heat. Without this protective barrier, the furnace simply could not operate continuously. Moving dozens of tons of glowing steel through a furnace is another remarkable engineering challenge. Hidden beneath each slab is a carefully synchronized roller hearth consisting of heavy-duty rollers designed to withstand extreme temperatures while transporting steel with exceptional precision. Each roller rotates at exactly the right speed to maintain smooth movement through every heating zone, quietly keeping production flowing every second of every day. Although the furnace appears to be a massive mechanical structure, it is also an intelligent machine. Hundreds of sensors continuously measure temperatures, fuel flow, combustion conditions, pressure, oxygen concentration, roller position, and countless other operating parameters. Every measurement is transmitted in real time to the control system, allowing the furnace to respond instantly to even the smallest operating changes. Collecting information is only the beginning. The true intelligence of a modern reheating furnace lies inside its control system. Every second, thousands of sensor readings are analyzed to maintain perfect operating conditions. The system continuously adjusts hydrogen flow, combustion air, burner output, roller speed, and furnace pressure to ensure every steel slab receives exactly the right amount of heat. Behind the glowing flames is a digital brain balancing efficiency, safety, and product quality simultaneously. Even in one of the world's most efficient heating systems, enormous amounts of thermal energy would normally escape through the exhaust. Modern reheating furnaces capture much of this energy through sophisticated heat recovery systems. Hot exhaust gases transfer their energy to incoming combustion air before it reaches the burners. Instead of wasting heat, the furnace recycles it, reducing hydrogen consumption while improving efficiency. After transferring as much useful energy as possible, the remaining gases leave the furnace through a carefully engineered exhaust system. Large insulated ducts guide hot gases safely away while maintaining stable furnace pressure. Dampers and flow controls continuously balance the entire system, ensuring combustion remains efficient and temperatures stay remarkably consistent. Operating above 1200 degrees Celsius while handling hydrogen fuel demands multiple layers of protection. Hydrogen leak detectors, flame detection systems, pressure monitoring devices, emergency shutoff valves, and automatic safety interlocks continuously protect both equipment and personnel. These hidden safety systems rarely attract attention, yet they quietly safeguard the furnace every moment it operates. After completing its carefully controlled journey, the steel finally emerges transformed. The once dark, rigid slab now glows bright orange, carrying enormous amounts of stored thermal energy. Every millimeter has reached nearly the same temperature, making the material ready for rolling. Conveyor systems immediately transport the slab toward the next machine before valuable heat is lost. Inside the rolling mill, massive steel rollers apply thousands of tons of force as the glowing slab passes between them repeatedly. With every pass, the steel becomes thinner, longer, and closer to its final dimensions. What entered the furnace as a thick slab now begins its transformation into structural beams, pipelines, automotive sheet, railway rails, steel plate, and countless products supporting modern civilization. The journey that began with a single steel slab now reaches its destination. Finished steel becomes skyscrapers, bridges, ships, railways, automobiles, pipelines, wind turbines, factories, airports, power plants, and data centers. Although few people ever see the reheating furnace, nearly everyone depends on the products it creates every single day. For more than a century, steel production has relied heavily on fossil fuels. Today, hydrogen is changing that story. The same furnace, the same engineering, and the same high-quality steel can now be produced using clean hydrogen energy. Instead of rebuilding the entire industry, engineers are transforming the energy system that powers it. Replacing fossil fuels with hydrogen dramatically reduces the carbon footprint of one of the world's largest industrial sectors. Combined with renewable electricity, intelligent automation, advanced heat recovery, and efficient furnace operation, hydrogen provides a practical pathway toward cleaner steel production while maintaining the performance modern society demands. The steel plant of the future will look familiar yet operate very differently beneath the surface. Hydrogen infrastructure, digital twins, predictive maintenance, smart control systems, renewable electricity, and intelligent automation will work together as one integrated industrial ecosystem. It will be cleaner, smarter, more efficient, and more connected than ever before. Every generation leaves behind infrastructure that shapes the future. The bridges we cross, the buildings we work in, the railways connecting our cities, the offshore wind farms producing renewable electricity, and the factories manufacturing tomorrow's technologies all depend upon steel. Hydrogen-powered manufacturing provides an opportunity to build that future while dramatically reducing environmental impact. The reheating furnace is only one machine in a vast hydrogen ecosystem. Behind every electrolyzer, compressor, storage system, pipeline, fuel cell, power plant, hydrogen refueling station, and industrial facility lies another hidden engineering story waiting to be discovered. At H2 Hub by Renee Energy, our mission is to reveal the machines, systems, and engineering shaping the global hydrogen economy. Because the future of clean energy is built not only by innovation, but by understanding the remarkable machines working quietly behind it every single day.